Hello again. We're back here with our Algebra 2 video series, and we came across this interesting problem, simplify the expression where the base e is not the same as the base of our power, the log base e squared of 10. And some very interesting consequences come as a result of working this through. I'd like to show you how this works out. So first I'd like to work this through in a manual fashion using our log property that allows us to change the base of that exponent. We're going to start by writing e. And for our exponent, we're going to change base from base e squared into base e. And that brings us back to the property log base a of b is equal to the natural log of b over the natural log of a. And we've done this previous to this particular video. So in this case, in the numerator, in the exponent, I'm going to go ahead and work this through. It's going to be natural log of 10, where 10 is representing the b that you see right here. And then the denominator is going to be the natural log of e squared. When we see the natural log of e squared in the denominator of that exponent, we know now that we can actually reduce it. This simplifies out to the number 2. Let me work this out. This is e to the natural log 10 all over 2. And at this point, we want to do a little bit of work with that. That's going to be e to the 1/2 natural log of 10. We have a property that allows us to take that 1/2 up as a power. So if we do that, we're going to end up with this. That's e to the natural log of 10 to the 1/2 power. At this point, we do have a property that allows us to reduce the e to the natural log 10 to the half, and that's this property e. So the natural log of x is equal to x. Because they're inverses of each other, the composite function produces x. Therefore, our answer here is 10 to the 1/2 power, or the square root of 10. Well, once you do this once or twice, you're going to notice the pattern starting up. So before I go on to the proof of this, I'd like to go to the next page and show you an alternate method of solving this. And it is a method where we change this bottom base to achieve e squared as the bottom base. And it brings up a method such as this. E is equal to e squared to the 1/2. And by doing this little computation within our expression, we're going to manufacture the same base. So starting with this problem, we end up with e to the 2nd power to the 1/2 to the log base e squared of 10. And in essence, I'm artificially producing a couple of exponents, but by the commutativity property of multiplication, I can take the 1/2 that's located here and take it all the way outside. In other words, rearrange these as e squared to the log base e squared of 10 to the 1/2. It's a fancy math trick there. And as we finish this out, we see now we have identical bases. So by our earlier property, or by the definition of inverses, we can then see that the answer must be 10 to the 1/2. Of course, this half is simply coming down and working there. So the answer comes out to be the same, the square root of 10, by a slightly different method than we saw in the first problem. If we go on to the last part, let's actually show that the following is a true property. So for example, a to the log base a to the nth power. In other words, our nice little base in this logarithm is a power of a, but it is not exactly equal to a. We'll do this by the same method. A to the log base a to the n of b. In this case, we would write a to the nth power to the 1 over nth power log base a to the n of b. Rearranging these one more time, we get a to the nth That is to the log base log base a to the nth of b, and that's all to the 1 over n. Finishing out the computation, we end up with our property being exposed here, leading to just b to the 1 over n, which is the nth root of b. Put a green cloud around that one. So I suppose we could consider this a new property of logarithms.